prime numbers. A prime number series is of 2, 3, 5, 7 and so on. Any prime number greater than 3. Any prime number greater than 3. It is of the form 6k plus or minus 1. Vice versa, all the natural numbers which are of the form 6k plus or minus 1 may or may not be true. Vice versa, may or may not be true. The reverse case, all the natural numbers which are of the form 6k plus or minus 1 which may or may not be true. For example, 49. 49 is 6 into 8 plus 1. 6 into 8 plus 1. But 49 is the square of 7. So it is a composite number. 25. 25 it is 6 into 4 plus 1. This is a composite number. I hope the idea it is clear. If the number is a prime number, it should be of the form 6k plus or minus 1. It should be of the form 6k plus or minus 1. Based on this, let us discuss some very good problems. First problem. For first problem, now see here. P plus 2, P plus 4 are prime numbers. P plus 2, P plus 4 are prime numbers. How many prime values P takes? How many prime values P takes? There is a triplet P plus 2, P plus 4. This triplet is a prime number triplet. How many prime values P can take? Listen carefully to the solution structure. P plus 2, P plus 4. P plus 2, P plus 4. The lowest prime number is 2. So 2. 2 plus 2 it is 4. 2 plus 4 it is 6. Next prime number is 3. P equivalent to 3. 3 plus 2 5. 3 plus 4 7. Any prime number greater than 3, it is of the form 6k plus or minus 1. Greater than 3. 6k plus 1. So these 6k plus 1 and it is 6k plus 3 and it is 6k plus 5. Divisible by 3, divisible by 3. If I add two numbers which are divisible by 3, answer will be divisible by 3. So there is one value P plus 2 which is divisible by 3. Next it is 6k minus 1. 6k minus 1. 6k plus 1 and it is 6k plus 3. These is divisible by 3, 3 is divisible by 3. If P value is 6k minus 1, P plus 4 will be divisible by 3. If P value is 6k plus 1, P plus 2 is divisible by 3. So there is no triplet where all the three are prime numbers. This case not possible, this case not possible. 4 and 6 are even numbers. So the only case that is possible is P equivalent to 3. How many prime values P can take? Only one prime value P can take. I hope the idea it is clear. First question. Second one. P plus 14, P plus 26, P plus 14, P plus 26 are prime numbers. Are prime numbers. How many prime values? How many prime values P can take? How many prime values P takes? Listen carefully. Same idea we will solve. How many prime values P can take? P plus 14 and P plus 26. The lowest prime number is P equivalent to 3. 17. 26 plus 3, 29. Next prime number is 5. 5 plus 14, 19. This is 31. Next prime number greater than 5 is, one is 6k plus 1, another is 6k minus 1. If I take 6k plus 1, 6k plus 1, 6k plus 1 plus 14, 6k plus 15. These 6k plus 27. Divisible by 3, divisible by 3. 6k minus 1, these 6k plus 13, these 6 into k plus 2 plus 1, k plus 2, it is, I will call it as x. Similarly, it is 6k plus 25. This is 6 into k plus 4 plus 1. I will call it as 6y plus 1. That means if I take a prime number 6k minus 1, there are some p plus 14 values which is behaving of the form 6x plus 1, p plus 26, which is behaving of the form 6y plus 1. Now, if you observe 17, if I take 17 is 6 into 3 minus 1, 17 plus 14, 31, 17 plus 26, 43. It is possible. Let me take some other 2-digit prime number, 83. 83 plus 14, 97. 83 plus 26, 109. 83, 97 and 109 all are prime numbers. That means in a 2-digit number, I just took a sample 2 prime numbers. In a 3-digit number, there could be few prime numbers which will satisfy the condition. In a 4-digit number, there could be few numbers which will satisfy 2 digits, 3 digits, 4 digits, 5 digits. We do not know the right range of p. So it is getting into countable infinite. It is getting into countable infinite. I hope the idea it is clear. P plus 14, p plus 26 are prime numbers. How many prime values? First substitute 2. If I substitute 2 plus 14 is 16, 2 plus 26 is 28, even plus even, there exists no prime number other than 2, which is even. 2, 16, 28 is eliminated. So 3, 17, 20. 3, 17, 29. These possible, these also possible, and there are some prime numbers which are of the form 6k minus 1 possible. So many values plus 1 or 2 values, it will tend to countable infinite. Answer for this question is countable infinite. I hope the idea it is clear. 2 questions, very easy questions if you understand the logic. 2 questions. Next one, the same question can also be asked like this. P square plus 3p minus 1. If this expression gives a prime value, if this expression gives a prime values, how many prime numbers p can take? Another same way of approach but different variety of asking a question. How many prime numbers p can take? P square plus 3p minus 1. It is nothing but answer is a prime value. How many prime numbers p can take? First we will write p here and the expression in the question p square plus 3p minus 1. Lowest prime number is 2. So these are nothing but 2 square plus 3 into 2 minus 1. 4 plus 6, 10, 10 minus 1, 9. 9 is a composite number. Next it is 3. 3 square plus 3 into 3 minus 1. 9 plus 8, it is nothing but 17. 17 is a prime number. Any prime number greater than 3. 6k plus 1 or 6k minus 1. If I substitute, these are nothing but 6k plus 1 whole square plus 3 into 6k plus 1 minus 1. 6k whole square, 36k square divisible by 3. 2 into 6k, 12k divisible by 3. 18k divisible by 3. 3 divisible by 3. 1 minus 1, 0. That means it is perfectly divisible by 3. Again I am opening 36k square plus 12k plus 18k plus 1 plus 3 minus 1. Divisible by 3, divisible by 3, divisible by 3. 1 minus 1 cancel. 3 is divisible by 3. 6k minus 1 whole square plus 3 into 6k minus 1 minus 1. 6k whole square divisible by 3. 2 into 6k divisible by 3. Plus 1 divisible by 3. Plus 1 minus 1 gets cancelled, so all are divisible by 3. That means if I substitute any prime value greater than 3, whether it is 6k plus 1 or 6k minus 1, both are resulting in p square plus 3p minus 1 divisible by 3. If it is divisible by 3, it cannot be a prime number. So how many prime values P can take? P can take only one prime value, and the value is P equivalent to 3, and the expression value is 17. Idea clear? Every prime number greater than 3, it is of the form 6k plus or minus 1. 6k plus or minus 1. Concept 2. Concept 2. Another beautiful question, sir. Concept 2. Concept 2. Now, if you see here, 4 factorial, it is nothing but 4 into 3 into 2 into 1. Am I right? So, these divisible by 2, these divisible by 3, and it is divisible by 4. 5 factorial, it is 5 into 4 into 3 into 2 into 1. It is divisible by 2, it is divisible by 3, it is divisible by 5. Let P be 17 factorial plus 1. P be 17 factorial plus 1. How many prime numbers are there in the set? How many prime numbers are there in the set? Set is P plus 1, P plus 2, and so on up to P plus 16. How many prime numbers are there in the set? P plus 1, P plus 2, and so on up to P plus 16. Listen carefully. P plus 1, it will become 17 factorial. 1 plus 1, it is 2. 17 factorial, it is an even number. Why? Because 17 factorial is the product of all the natural numbers from 17 to 1. So it contains 2. This is divisible by 2. 2 is also divisible by 2. That means answer is divisible by 2. P plus 2, which is 17 factorial plus 3, divisible by 3. These divisible by 3. Answer is divisible by 3 because 17 factorial contains 3. P plus 3. These is nothing but 17 factorial plus 1 plus 3, 4. These is an even number, these is an even number. Answer is an even number. Any even number other than 2, it cannot be a prime number. P plus 16. It is 17 factorial plus 17, divisible by 17, divisible by 17. Answer should be divisible by 17. First case, P plus 1 is giving an even number. Second, P plus 2 is divisible by 3. P plus 3, it is an even number. P plus 16, it is divisible by 17. So, none of the value, it is giving a prime number. No prime numbers are there in the set. No prime numbers are there in the set. I hope the logic is clear. Very, very good question, sir. P equivalent to 2 more questions. 2 more questions. P equivalent to exam based question. P is 2017 factorial plus 1. How many prime numbers? How many prime numbers are there in the set? How many prime numbers are there in P plus 1, P plus 2, and so on up to P plus 2016. How many prime numbers are there in the set? Same logic, a CAT replica question, so that you are familiar with the concept. If it is P plus 1, 2017 factorial plus 1, it is 2. These divisible by 2. These 2 is divisible by 2. Answer is divisible by 2. Idea clear? P plus 2. These nothing but 2017 factorial plus 1 plus 2. It is 3. Divisible by 3. Divisible by 3. Answer, it is divisible by 3. And so on up to P plus 2016. It is 2017 factorial 17 divisible by 2017, divisible by 2017. Answer is divisible by 2017. I hope it is clear. No prime numbers are there in the set. Exam model questions, very, very important. Different kinds of prime number questions. Divisible by 2, divisible by 3, divisible by 2017. No prime numbers are there in the set. Next one. N equivalent to P plus X. P is the product of all prime numbers. P is the product of all prime numbers less than or equivalent to, product of all prime numbers less than or equivalent to 31. X is a natural number from 2 to 29. 2 to 29. For how many values of X? For how many values of X is n prime number? How many values of X is n prime number? Another model. N equivalent to P plus X. P is the product of all prime numbers less than or equivalent to 31. P plus X. P is the product of all prime numbers 2, 3, 5, 7 and so on up to 31. X lies in the range, either it can be 2 or it can be 3 or it can be 4 or it can be 29. For how many values of X is n prime? See here, these divisible by 2. 2 is divisible by 2. Even plus even, it is an even number. Any even number other than 2, it cannot be a prime number. These divisible by 3. These 3 is divisible by 3. Answer will be divisible by 3. Next, it is an even number. 4 is an even number. Answer will be divisible by even number. This is 29. Here also 29 is present. These divisible by 29. 29 is again divisible by 29. Every term, if you see, whatever the elements that are there in X, whether it is 2, 2 is a part of P. If it is 3, it is a part of P. If it is 4, right, the factor of 4 is a part of P. 5 is a part. 6, if it is a composite number in X, the factors of that composite number are present in P. So everything will become a multiple of K. K could be 3, K could be 5, K could be and so on up to 29. No value of X will make n prime number. I hope the idea it is clear. No value of X will make n prime number. Very, very good questions. Based upon this one, let us solve some previous year CAT questions. Some previous year CAT questions. Now see here, what is that question? These already we solved. P plus 2, P plus 14. Here P, if it is 2, 2 plus 2, 4. 2 plus 14, it is 16. If it is 3, 5 and 17. If it is greater than 3, 6k plus 1, 6k plus 3 and 6k plus 15. Divisible by 3, divisible by 3. 6k minus 1, these 6k plus 1, these 6k plus 13, these 6k minus 1, these 6k plus 1, these 6x plus 1. X is k plus 2. If I take 17, 17 plus 2, 19, 17 plus 14, 31. You are getting it. Let me take 29. 6 into 5 minus 1. 29 plus 2, 31. 29 plus 14, it is 43. 29, 31, 43. Like that there exists so many 2-digit numbers, right, which satisfy this question. 2 digit it satisfies, 3 digits it satisfies and so on. It is infinite. This model we covered. This model also we covered. P take 2, P take 3, any prime number greater than 3, 6k minus 1 or 6k plus 1. Directly 2 plus 6 it is 8, so this is not giving. 3 plus 2 it is 15, it is not giving. 6k minus 1, 6k minus 1. So if it is 6k minus 1 and 6k plus 1, so these 6k minus 1, these 6k minus 1 plus 6. These 6k minus 1 plus 12, 6k minus 1 plus 18, 6k minus 1 plus 24. I hope it is clear. So these is nothing but 6k plus 1, 6k plus 1, 6k plus 1 plus 6, 6k plus 1 plus 12, 6k plus 1 plus 18. These 6k plus 5 when divided by 6, remainder 1. Check if more than one value satisfies. If more than one value satisfies, answer is nothing but countable infinite. This question also we solved it. Now see this CAT question. P is equivalent to A plus B. A is the product of all prime numbers less than 62. So it is 2, it is 3, 5, 7 and so on up to last prime number, it is 61. B can take any natural number. B can take any natural number. B is a natural number here. Right? So B can take 2, 3, 4 and so on up to 61. 2 is a part of this number. 3 is a part of this number. Factor of 4 is a part of this number. 61 it is a part of the number. No value of B. No value of B satisfies this equation. Various models is what we are looking at in prime numbers. Now again a CAT level question. If P is a prime number such that 2016 factorial plus 1. Next number is 2016 factorial plus 2. Next number is 2016 factorial plus 3. Last number is 2016 factorial plus 2015. All are prime number is a subset of natural numbers. This is an even number. 2 is an even number. Answer will be even number. Divisible by 3. Divisible by 3. Answer is divisible by 3. Divisible by 5. Divisible by 5. Answer is divisible by 5. How many prime values P can take? No value. No prime value P can take. I hope the idea it is clear. No prime value P takes. No prime value P takes. Once you know all the models, this model already we have seen. These also we have seen in session number 2. N cube minus 8n square plus 20n minus 13 for how many positive integer values of n such that this cubic expression it is a prime number such that this cubic expression is a prime number. Lowest positive integer it is 1. So if I substitute 1 minus 8 plus 20 minus 13, 21 minus 21, 0. That means if the remainder is 0, n minus 1 is a factor. N minus 1 is a factor of this expression. Now let us do synthetic division. What is synthetic division? Synthetic division helps us in finding the quotient. Helps us in finding the quotient. How to do it? N cube coefficient it is 1. N square coefficient it is minus 8. Coefficient of n it is 20. And these nothing but minus 13. N minus 1 is a factor. So n minus 1 equated with 0. N equivalent to 1. Starting with 0. N cube coefficient and n coefficient both are same. 1 plus 0 it is 1. 1 ones are 1. Minus 8 plus 1. Minus 7. Minus 7 into 1. Minus 7. 20 minus 7. 13. 13 ones are 13. Remainder it is 0. Remainder it is 0. So n minus 1 it is a factor. Next will be out of cubic n minus 1 is a factor. It is nothing but n square minus 7n plus 13. N square minus 7n plus 13. Now see here. Let us check whether this expression is meeting or not. N into n square, n cube, minus n into minus 7, n minus 7n square, minus n square, minus 8n square, 13n. 13n plus 7n, 20n minus 13. This is n minus 1. It is a factor. This is a discriminant. B square minus 4ac minus 52. It is less than 0. That means roots are imaginary. That means the roots are imaginary. So I am getting 1, I1, I2. I hope it is clear. 1, I1, I2. Again I am repeating. N cube minus 8n square plus 20n minus 13. This is a cubic expression. He is asking how many positive integers n can take. N value 1. It is n minus 1 is a factor. Then do synthetic division. Synthetic division helps us in finding the quotient. N minus 1 it is 0. 1 minus 8, 20 minus 13. 1 plus 0, 1. cross multiply, 1 ones are 1, minus 8 plus 1, minus 7, cross multiply, 20 minus 7, 13, 13 ones are 13. So when a cubic is divided by linear, remaining is n square minus 7n plus 13. The discriminant of these equation is less than 0. That means the roots are imaginary. Roots are imaginary. N value 1. I am getting 0. 0 is not a prime number. Remaining 2, n is giving me imaginary value. So it will not satisfy. Good question, which will teach you how to do synthetic division. I hope the idea it is clear. This question also we have done it. Now let us solve some more good models based on this one. Then we will get back. Right. Now let us see some models. What is that we discussed? Concept 1, concept 1, concept 2. These is nothing but any prime number greater than 3. Any prime number greater than 3. It is of the form 6k plus or minus 1. Next question is n equivalent to p factorial plus 1. Determining how many prime numbers are there. Determining how many prime numbers are there. Concept 3. How to use synthetic division. How to use synthetic division to find out the quotient. How to use synthetic division to find out the quotient. Let me explain synthetic division. It probably only one problem we solved. You might get a doubt. Synthetic division. Now see here. First one, factorize. Factorize. One by one we will solve. First one, x square minus 5x plus 6. By using synthetic division we will do. If x equivalent to 1, 1 minus 5 plus 6. 1 minus 5 plus 6. 7 minus 5, 2. 2 is not equivalent to 0. X equivalent to 1 is not x equivalent to 1 is not giving you 0. Then take x equivalent to 2. I am taking the factors of the constant. X equivalent to 2. 2 square minus 5 into 2 plus 6. 4 plus 6, 10. 10 minus 10. 10 equivalent, right? 10 minus 10. It is equivalent to 0. That means x minus 2 is a factor. X minus 2 is a factor. How to generate another factor? Simply you all know that it is x minus 2 into x minus 3. By using synthetic division, how to get x minus 3? Write coefficient of x minus 5. Constant it is nothing but 6. X minus 2 is a factor. X minus 2 is equivalent to 0. X is equivalent to 2. Start with 0. 1 plus 0, 1. 1 2s are 2. Minus 5 plus 2. Minus 3. 2 into minus 3. Minus 6. 6 minus 6, 0. That means one is x minus 2 is a factor. Another is x minus 3 is a factor. Extremely useful for degree 3, degree 4. For degree 2, probably if you can factorize it, you can use that concept. X minus 2 into x minus 3. I will take another degree 3, then I will explain you. Synthetic division, I hope it is clear. Let us take B. Question. X cube minus 5x square minus 5x square. Suppose plus 3x. Plus 3x. These minus 1. 3 minus 1, 2, 2, 2 minus 5, 1 minus 5, minus 4, minus 4 plus 3, minus 1 plus 1. Factorize. Let us solve this question. Factorize this one. X cube minus 5x square plus 3x plus 1. Now see, if x equivalent to 1, 1 minus 5 plus 3 plus 1. 5 minus 5, it is 0. That means x minus 1 is a factor. X minus 1, it is a factor. If x minus 1 is a factor, write down the coefficient of x cube 1. It is minus 5. This is 3 and it is 1. Start with x minus 1 is a factor. Equate it with 0. X equivalent to 1. Start with 0. Coefficient of x, coefficient of x cube. Both are same. 1 plus 0, 1. Cross multiply. 1 ones are 1. Add it. Minus 5 plus 1, minus 4. Cross multiply. Minus 4. 3 minus 4, minus 1. Minus 1 into 1, minus 1. 1 minus 1, 0. 1 minus 1, 0. That means it is x minus 1 is a factor. Degree is 3. I got degree 1. Next it is x square minus 4x minus 1. X square minus 4x minus 1. This is how you can find out the roots of this equation. We will discuss in detail algebra because I got a cubic equation, right? Just I am introducing you, right, to an synthetic division. See here, sir, if a polynomial function is divided by dividend divisor, you will get R Q of x, which is quotient, R of x, which is the remainder. These is nothing but the quotient. These is nothing but the remainder. These is nothing but the remainder. Dividend equivalent to. Dividend is the number which is getting divided. These is dividend. Dividend equivalent to divisor into quotient plus remainder. Divisor into quotient plus remainder. D of x is the divisor. Q of x is the quotient. R of x is the remainder. That means in the expression P of x and D of x will be given. P of x and D of x will be given. This will be given. This will be given. This we can determine by using synthetic division. Remainder also we can determine by using synthetic division. I hope you got the idea. Next, concept number 4. Two more concepts we will discuss in detail. Concept 4. These are another variety of questions. P1 into, P2 into, P3 into, P4, P5, P6, P7. P1, P2, P3, P4, P6, P7. The entire multiplication, it is 510, 510. All these numbers, P1, P2 till P7, all these numbers are prime numbers. All these numbers are prime numbers. So if the question is P1 less than, P2 less than, P3 and so on up to less than P7, find the value of P1. Find the value of P1. P1 is how much? We will determine all the values of P1 to P7 so that you will understand the various divisibility rules. Now see here. P1, P2, P3, P4, P5, P6, P7. The product is 510, 510. 510, 510. It is an even number. If I take all the prime numbers as odd numbers, if I take all the prime numbers as odd numbers, odd into odd into odd and so on up to odd, answer will be odd. All the prime numbers, if I take, the answer will be odd. But in the question, it is given as 510, 510, which is an even number. All the 7 cannot be an odd number. One number has to be even. Only one number will be even in the set of prime numbers. So P1 is nothing but 2. P1 is nothing but 2. All the 7 cannot be odd, 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 odd. I will get odd. Only one has to be an even number, because in a prime number set, the only even number possibility is nothing but 2. Now, if you see carefully, I discussed in the previous session, any 3-digit number written even number of times is always divisible by 7, 11, 13. These 7, these 11, and it is 13. It is ending with 0. So if I multiply by number by 5, unit digit will be 0. Sum of the digits 6 plus 6, 12. It is divisible by 3. I hope it is clear. Next, it is also divisible by 2. 2 into 3. Now if you see here, these 7 prime numbers, 1, 2, 3, 4, 5, 6. After 13, what is the next prime number? 17. 17, 30s are 510. So we got the answer as 2, 3, 5, 7, 11, 13, 17. Idea it is clear. Just by looking at the question, you can find out the values of P1 to P7 if you know the divisibility rules of some selected prime numbers. Concept number 4. I hope it is clear. First problem. Second one. P1 plus P2 plus P3 plus P1, P2, P3, P4, P5, P6, P7. Just I am twisting the question. Equivalent to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Find the value of P1 if all the numbers are prime numbers. P1 to P7, all are prime numbers. Find the value of P1. Find the value of P1. Now see here, if all are odd numbers, if all the numbers are odd numbers, if I take all the numbers as odd numbers, odd plus odd even, odd plus odd even, odd plus odd even, plus odd number. So answer will be an odd number. But the right hand side, it is 1, 2, 3, 4, 5, 6, which is an even number. All the numbers odd numbers, not possible. One has to be even. What is the smallest prime number and even? Answer is nothing but 2. Answer is nothing but 2. Very, very easy. If you do it, right, only the value of P1 is required. P2, P3, P4, P5, P6, P7 may take any other value. So, again I am telling odd number of odd numbers. Some will be an odd number, but in the right hand side it is an even number. So, one number has to be an even number. Idea clear? Next, another variety. Wilson's theorem application. Wilson's theorem application. What is Wilson's theorem? Reminder, when P minus 1 factorial plus 1 when divided by P, remainder is always 0 if P is a prime number. P minus 1 factorial plus 1 when divided by P, remainder it is always 0 when P is a prime number. Let us cross check whether this notation is right or wrong by taking P value 5. This is nothing but 5 minus 1, 4 factorial plus 1 divided by 5. 25 divided by 5. What is the remainder? 0. If P value, if it is 3, this will become 3 minus 1 factorial. 2 factorial plus 1 when divided by 3. Again the remainder is 0. I hope it is clear, right? P minus 1 factorial plus 1 when divided by P, remainder is always 0, right? As long as P is a prime number. Another important case, P minus 1 factorial is never divisible by P. P minus 1 factorial is never divisible by P for dash number of values of P. P is less than 30. P is less than 30. P minus 1 factorial is never divisible by P for dash values of P. P is a natural number here. Factorial is there starting from 0 factorial, but here he gave P is a natural number. Factorial only executes for a whole numbers. P minus 1 factorial plus 1 is not, plus 1 is not there. P minus 1 factorial is never divisible by P. Let me take P value 1. 1 minus 1 factorial, 0 factorial. 1 is divisible by 1. If P is 2, 2 minus 1 factorial, it is 1 factorial. Is 1 divisible by 2? No. If P is equivalent to 3, 3 minus 1 factorial, 2 factorial. Is 2 factorial divisible by 3? No. This case possible. P equivalent to 4, 4 minus 1 factorial, 3 factorial. Is 3 factorial 6 divisible by 4? No. If P 5 minus 1 factorial, 4 factorial is 24 divisible by P? No. If P is 6, 6 minus 1 factorial, 5 factorial, 120 divisible by 6. If P is 7, 8, we will stop it here because I want to derive. 8 minus 1, 7 factorial, 8 minus 1, 7 factorial. 7 factorial is nothing but 7 into 6 into 5 and so on up to 4 into 3 into 2 into 1. It is divisible by 8. Now, if it is divisible, where all cross marks we got, if you observe, you will get the answer easily. Cross marks we got P equivalent to 2, prime number, P equivalent to 3, prime number, P equivalent to 5, prime number, P equivalent to 7. And in addition, we got a case P equivalent to 4. That means P will take all prime numbers. P will take all prime numbers and 4. P will take all prime numbers and 4. A CAT and an other exam replica questions. P will take all the prime numbers and 4. So P will take 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 and 4. These all values it will take. How many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. For how many values of P? That P minus 1 factorial is never divisible by P. All the prime values of P and P equivalent to 4. And P equivalent to 4. I hope the idea it is clear. Lot of previous year exam questions came from this concept. P minus 1 factorial is never divisible by P. Is never divisible by P for all prime values of P, for all prime values of P and P equivalent to 4 and P equivalent to 4. Please make a note of these two important conditions. P minus 1 factorial is never divisible by P. Next one it is, now we will see Wilson's theorem application. P minus 1 factorial plus 1 when divided by P, it is 0 as long as P is a prime number. As long as P is a prime number. I hope the idea it is clear. If P is a prime number, you can use Fermat's theorem, you can use Wilson's theorem, and you can use the divisibility rule to get the remainders. Now, application of Wilson's theorem. Let us see. Wilson's theorem application. A 10 minutes concept on application that completes the basic level understanding of prime numbers. Wilson's theorem application. First question. Remainder 1. 9 factorial divided by 7. 9 factorial divided by 7. 9 factorial contains 7. So answer is 0. Why? Because 9 factorial is 9 into 8 into 7 and so on up to 3 into 2 into 1. 9 factorial contains 7. So answer is 0. One more similar question based upon this one. 23 factorial divided by 17. 23 factorial contains 17. Answer is 0. 23 factorial, it is contains 17. So answer is 0. Next one. Third one. Remainder 1. 16 factorial is divided by 17. Remainder 1. 16 factorial is divided by 17. These nothing but 17 minus 1 factorial plus 1 minus 1 divided by 17. Already we have seen P minus 1 factorial plus 1 divided by P. It is 0. Negative remainder minus 1. Positive remainder will be 16. Positive remainder will be 16. P minus 1 factorial plus 1 when divided by P. Positive remainder will be 0. 0 minus 1 minus 1. If you get a negative remainder, add it with the denominator. If you get a negative remainder, add it with the denominator. Remainder 1. 22 factorial is divided by 23. These are nothing but 23 minus 1 factorial plus 1 minus 1 divided by 23. P minus 1 factorial plus 1 divided by P. it is 0. Again it is minus 1. Minus 1, 23 minus 1. What is the positive remainder? 22. Some conclusions are also given by Wilson's theorem. We will write that conclusions. In case if you forget it, then we will discuss the step-by-step approach. What are the conclusions? P minus 1 factorial divided by P. It is always P minus 1 when P is a prime number. It is always P minus 1. Reminder 1. P minus 2 factorial. P minus 2 factorial divided by P. It is always 1. Reminder 1. P minus 3 factorial divided by P. It is always P minus 1 by 2. Whether if P is a prime number, here also P is a prime number. In case if you forget these conclusions, I will tell you the way to get the answer going step by step. Please make a note of it. P minus 1 factorial divided by P, it is P minus 1. P minus 2 factorial divided by P, it is 1. P minus 3 factorial divided by P, it is P minus 1 by 2. Directly you will get the answer. 14 factorial divided by 17. 17 minus 1, 16 by 2, 8. Reminder 1. 34 factorial divided by 37. P minus 3 factorial. 36 by 2. Answer is 18. In this, reminder of 17 factorial by 19. P minus 2 factorial by P. Answer is nothing but 1. Reminder of 40 factorial by 41. P minus 1 factorial by P. Answer is P minus 1. 41 minus 1. Answer is 40. Directly you can do it. In case if you probably forgot this concept, we will go step by step. P minus 1 by 1 factorial by P is P minus 1. P minus 2 factorial by P is 1. P minus 3 factorial by P is P minus 1 by 2. Now see here. Suppose if the question is reminder 1, 15 factorial by 17 is there. In case if you forget the approach, otherwise we got the answer as 1. Use this method of backtracking. Just now we solved 16 factorial by 17, which is nothing but P minus 1, which is 16. Just through visualization you will get the answer. 16 factorial is 16 into 15 factorial divided by 17. 16 by 17. 17 zeros are 0. Reminder it is 16. 16 into something divided by some 17. Reminder should be 16. That something has to be 1 only, right? 16 ones are 16. 16 divided by 17, it is 16. That something is nothing but 1. I hope the idea it is clear. Suppose in case if the idea it is not clear. 29 factorial by 31. Now if you observe carefully, 30 factorial by 31. P minus 1 factorial by P, it is nothing but 31 minus 1, which is 30. 30 factorial, it is nothing but 30 into 29 factorial divided by 31, it is 30. 30 by 31, it is 30. 29 by 31, question mark, divided by 31, it is nothing but 30. Just by looking at a question itself, we can say that the answer is 30. I hope the idea it is clear. Answer is 30 just by looking. Otherwise, you can use the conclusion. P minus 2 factorial by P. Answer is nothing but 1. P minus 2 factorial divided by P. Answer is nothing but 1. Now, suppose P minus 3 factorial. For example, 10 factorial by 13 is there. You forgot the concept of P minus 1 by 2. We will keep the answer here as 13 minus 1 by 2, which is 6. We'll keep it here. Now we will go step by step. These are nothing but 11 factorial by 13. How much we got the answer? 1. 11 factorial is nothing but 11 into 10 factorial divided by 13. Answer is how much? 1. 11 divided by 13, it is 11. 10 factorial divided by 13, x. If the numerator is less than the denominator, how many times you divide? Answer will not change. 11 divided by 13, 11. 10 factorial divided by 13, x. If the numerator is less than the denominator, see this example, 9 into 7 by 2, 9 by 2, 1, 7 by 2, 1. If I further divide, answer will not change. Are you all with me? If I further divide, answer will not change. 11x is divided by 13. I don't know the quotient k, but I know the remainder as 1. Dividend equivalent to, what is the concept? Dividend equivalent to divisor into quotient plus remainder. Dividend equivalent to divisor into quotient plus remainder. 11x is nothing but 13k plus 1. 11x is nothing but 11k plus 2k plus 1. 11k plus 2k plus 1. Now if you see here, divisible by 11, divisible by 11. This should be divisible by 11. That means k minimum value, it is nothing but 5. K minimum value, it is nothing but 5. I hope it is clear. Sir, can't I take k value 16? Yes, that also you can take. That will give the same answer. 2k plus 1 equivalent to 11. K value is nothing but 5. So 11x is 33, 5, 13 5s are 65. 65 plus 1, 66. X value is nothing but 6. X value is nothing but 6. Suppose if I take 16, 13 16s are 208. 208 plus 1, 209. X I got 19. When you divide a number by 13, you will not get the remainder 19. 19 divided by 13. 13 ones are 13. What is the answer? 6. I hope the idea it is clear. Dividend equivalent to divisor into quotient plus remainder. Lowest value you take the highest value. Still the answer will be same. 11x is 11k plus 2k plus 1. Divisible by 11, divisible by 11. K value it is 5. 11x is 66, x value it is 6. Idea clear, right? One more question we will solve so that you will get a very good idea about how to solve this kind of question without even remembering the conclusion. 16 factorial by 19. 16 factorial divided by 19. These are nothing but 17 factorial divided by 19. It is nothing but 1. 17 factorial is 17 into 16 factorial divided by 19, it is 1. 17 by 19, 17. 16 factorial by 19, x. When I further divide, remainder does not changes. Dividend equivalent to divisor into quotient plus remainder. 17x equivalent to 17k plus 2k plus 1. 17x divisible by 17, divisible by 17. 2k plus 1, it should be divisible by 17. K value, it is 8. So 17x equivalent to 152 plus 1, 153. X is nothing but 9. X is nothing but 9. 9 is nothing but 19 minus 1 by 2. 19 minus 1 is 18. 18 by 2, it is nothing but 9. This is the step-by-step process. From this, if this step is clear, you will get the answer. 17x is dividend. 19 is divisor. K is quotient. 1 is remainder. Dividend equivalent to divisor into quotient plus remainder. I hope the idea it is clear. Two more questions in this model we will discuss so that you will understand the mistake that is present in most of the textbooks. 8 factorial whole square divided by 17. 8 factorial whole square divided by 17. See here. Remainder 1. Remainder 15 factorial divided by 17. 15 factorial divided by 17. These are nothing but 17 minus 1 by 2. 16 by 2, it is 8. I hope the idea it is clear. 15 factorial is 1 into 2 into and so on up to 8, 9, 10, 11 and so on up to 17 divided by, 15. 15 divided by 17, it is nothing but 8. It is nothing but 8. Remainder of 1 to 8, it is 8 factorial. I hope it is clear. 9 divided by 17 minus 8. 10 divided by 17 minus 7. 15 divided by 17 minus 2. Divided by 17, it is nothing but 8. Again I am repeating, 9 divided by 17. 17 ones are 17, minus 8, minus 7, minus 2. 2 to 8, there are 7 negatives are there. 7 negatives, if I multiply, I will get another negative. Minus into 8 factorial divided by 17. It is nothing but 8. 8 factorial whole square divided by 17. It is minus 8. Negative remainder 8. Positive remainder 17 minus 8, 9. 15 factorial is 1 into 2 and so on up to 15. These are nothing but 8 factorial. 9 by 17 minus 8 minus 7 and so on up to minus 2. Another 8 factorial is coming. 2 to 8 total 7 negatives are there. So minus 8 factorial we got it. Minus 8 factorial we got it. Now another question let us solve. Remainder 1. 35 factorial whole square divided by 71. 35 factorial whole square divided by 71. These are nothing but remainder 69 factorial divided by 71. P minus what we took in the previous question. These are nothing but in the previous question 15 factorial by 17, we took it as 1, right? I think 15 factorial, it is 1 into 2 till 8, 9. P minus 2, we took it as 1 only, right? Into 15 divided by 17, it is 1. These 8 factorial. I hope the idea it is clear. 9 by 17 is minus 8 and minus 2. Divided by 17 equivalent to 1. These 2 to 8, it is a negative 8 factorial whole square divided by 17, it is minus 1. 17 minus 1 is 16. 8 from 15 factorial by 17, you can derive 8 factorial whole square by 17. Calculations, please don't do any mistake. If I do any calculation mistake, please correct it yourself. These nothing but 1. 69 factorial is 1 into 2 till 35. Next it is 36 till 69 divided by 71. It is nothing but 1. Till here clear, right? Now 1 into 2 till 35. These are nothing but 35 factorial. 36 by 71 minus 35. Minus 34, 69 by 71 minus 2 divided by 71, it is 1. 2 to 35, 34 negatives are there. So it is nothing but 35 whole square divided by 71. Answer is 1. 35 factorial whole square divided by 71, it is 1. 15 factorial whole square divided by 17 is resulting in 8 factorial whole square divided by 17. So sometimes you are getting a P minus 1. Sometimes you are getting right 1. So these are the two cases. Don't generalize it and take it as P minus 1 always. Sometimes it is 1. Sometimes it is P minus 1. All the 5 varieties of prime numbers we discussed in details.